Good evening, my dear students of class 12. So, today I would like to make you understand the interference of light. So, before going to the interference of light, we must not forget he is Thomas Young, who has a British scientist and is a great contribution to the field of physics and maths. He today will be reading about his double slit experiment as well. So before going to the topic of double slit experiment, we should know the term what is interference. इंटरफेरेंस का मतलब क्या है वह जानना बहुत ही ज़रूरी है। अगर हम देखते हैं कि कोई भी एक सोर्स ऑफ लाइट जो है, जब कोई एक सोर्स ऑफ लाइट से लाइट एनर्जी एमिट होती है तो जिस मीडियम में वह यूनिफॉर्म की तरफ फैल जाता है, पर when there is two sources of light and they are very close to each other, having more or less the same wavelength and amplitude, then what happens? Then the waves gets overlap. That means there is due to the superposition of the waves, what happen is due to the superposition of the waves, there is no longer uniform in the medium. So what happens? There it becomes in some point in the medium there is a constructive interference, and some point in the medium there is a destructive interference. That means what? We in the medium, when the waves of same amplitude at destructive impedance, it is completely dark. So somewhere we get dark and somewhere we get bright. That means what? This getting of such things is what we say is interference of fringes. So you can see this arrangement. This arrangement is said to be what? Double slit experiment done by Thomas Young. Actually, during this experiment, his experiment has given a great blow to the corpuscular theory of light, and by giving the conclusion that light have wave in nature. So during this experiment, he has taken a monochromatic light of source, that is S, and there are two slits. You can see over here S1 and S2, which are very close to each other and has an equal distance from the source of light. There is a giant screen behind over here. Now what happens when there is a monochromatic source, from monochromatic source of light, it emits to the slit S1 and S2, from where the wavefronts gets proceed on in the medium, and in the medium they spread out throughout and forming the and they superimpose on the screen, forming bright and dark fringes. But at the center here the intensity is maximum. You can write over here the intensity is maximum. So we can see over here on the screen there is a dark and bright fringes on the screen, where the intensity at the center that is at O, this position, it is maximum. So now we'll try to find it out why intensity is maximum. Intensity of light is maximum over here. It is also called central maximum. Why? What happens? We have already learned regarding with the help of Huygens principle that when the waves of from this two S1 and S2, when it forms of same amplitude and same wavelength throughout this medium are in the phase. Since from the distance from S1 to O and S2 to O is same, so here either the crest of one wave over superposed with crest of another wave, or the trough of one wave superimposed with the trough of the other wave. Hence the causing here maximum intensity of light, forming central maximum. Now we can see here that there is D1 below O and above B1 below O and the above O there is also B1. Like this we get D1, D2, here also D1, D2 we get, which is not shown in the figure. What is D1? This is a destructive. During here, what happens in this position, the trough of one wave falls on the crest of other wave or vice versa. So forming here, what happens, the intensity of light becomes less, minimum, forming dark fringes. That means here it is a destructive. Again on bright fringes, what happened here, it is the crest of one superpose with the crest of the other, or the trough of one wave superpose with the trough of other wave, forming bright fringes. This is what we say is constructive. From the following facts can be verified, that is, if one of the two slits is closed, we have seen as monochromatic light from source and there are two slits are being used. If one of the two slits is shut down, if it is closed, then there is no interference, then interference gets disappeared. That means there gets no interference. Why? Because the source of light is a single source of light is there, and through which the intensity of light, which or we can say the energy which is being emitted, gets uniformly distributed, and hence we doesn't get any fringes, or we can say that there is no superposition of waves over there. Number two, we can also that two independent source, instead of a single source is being used for two slits, instead of that if we use two independent source, then what we can see that the interference pattern would not be in a permanent way, it would have been in a temporary way. So the facts can be taken out from the Young's double slit experiment. Now we'll try to understand the condition for constructive and destructive. This is a screen and this is the central maxima. This is a source of monochromatic light, and S1, S2 are slits which are very close to each other. So forming the waves over here, the wave forms throughout it gets distributed and forming the dark and bright fringes over here. Now let us consider that at any time t, the displacement of the wave through S1 and S2 be y1 is equals to a1 sine omega t, and y2 is equals to a2 sine omega t plus phi, where phi is the constant phase difference between the waves. Then the resultant displacement we would get. Now we'll try to find out the resultant displacement. On adding y1 plus y2, we get this plus this. So from this we already know that here sine omega t plus phi, we know that sine a plus b formula. So finally sine a plus b means sine a cos b plus cos a sine b. In the same term we are using in this way. So when we finally get the result, we are getting sine omega t a1 plus a2 cos phi plus a2 cos omega t sine phi. See here we are getting omega t over here, omega t over here. So we can consider this position as, let us consider a1 plus a2 cos phi as a cos theta, and let us consider a2 sine phi as a sine theta. Then finally what we get is a sine omega t cos theta plus a cos omega t sine phi. So similarly, if we go with this, it is in the form of sine of a plus b form, we can write it as. So at point P, the final displacement we can get in the form of this, which is again this having the amplitude A. So this is in a simple harmonic wave motion. Simple harmonic wave motion. Now, in order to find out the amplitude, already we know that we have taken a cos theta is equals to a1 plus a2 cos phi, and a sin theta is equals to a2 sin phi. So, to find out the amplitude, we can square this, and we get as a square cos square theta plus squaring this a square sin square theta is equals to square of this is a1 square plus a2 square cos square 5 plus 2a1 a2 cos 5 plus a2 square sin square 5. So from this a square cos square, we can take a square as common, then cos square theta plus sin square theta is 1. So we can write down here as a square is equals to, from here we can write a1 square, now a2 square cos square 5 plus a2 square sin square 5 is a2 square plus, we can write this one as 2a1 a2 cos 5. Now intensity is that proportional to the square of the amplitude, so instead of this we can write here intensity is equals to a1 square plus a2 square plus 2a1 a2 cos 5. So already we got the equation I is equals to a1 square plus a2 square plus 2a1 a2 cos 5. Okay, so for constructive interference, cos phi must be equals to plus 1, that is the maximum intensity of light. So cos phi is equals to 1 implies that phi is equals to 2n pi. And for destructive interference, cos phi should be equals to minus 1. So finally phi must be equals to 2n plus 1 into pi. Thank you.